This is Mr. Beck Does Your Homework, AP Physics, Homework 3.2, question number 9. An Olympic skier moving at 20 meters per second down a 28-degree slope encounters a region of wet snow of coefficient of kinetic friction, mu is 0.66. So I've got my slope, I've got 28 degrees is this. I've got my skier, and I'm just going to draw my skier as a box, nice and easy. So I've got 28 degrees here. I've got my skier, and it's going to come down and hit a coefficient of friction. How far down the slope does she travel before coming to a halt? Well, that means she's going to accelerate. So I don't know my acceleration. I'm looking for how far she travels. I know that her initial velocity is going to be 20 meters per second. And I know that her final velocity is going to be 0. So this looks like I'm going to use the v squared is v0 squared plus 2ax equation. But I'm missing something. I'm looking for x, but I don't have a either. So it looks like I'm going to have to get a from the forces on this block, or sorry, on this skier. So, free body diagram. I've got gravity straight down. I have a normal force up this way. And I have friction back this way. And those are going to be all of the forces acting on my skier. Well, my gravity is going to be my mass times the acceleration of gravity, but I don't know her mass yet. Well, we'll worry about that later. My normal force is going to be some component of gravity, because gravity is my monster in this case. So what I want to do is split gravity into its components. So I'm going to take my gravity, which right now is straight down, and turn it into some component down the ramp and some component into the ramp. So this is going to be my Fg in, and this is going to be my Fg down, if this is my Fg. So this angle is also going to be 22 degrees, so down is going to be sine theta. So I know that my force of gravity down is going to be mg sine theta. I know that my force of gravity into the slope is going to be mg cosine theta. So I've got down the slope and into the slope, mg sine theta, mg cosine theta. Wait, I still don't know mass. Well, let's see how that works out. So my normal force in this case, if I break gravity into in and down, well, if I redraw my free body diagram, I've got gravity in, I've got a normal force, I've got gravity down, and I've got my friction. So which one of these do I know? Turns out that I know gravity down, except I don't have the mass, and I know gravity in, except I don't have the mass, and I know my normal force because it's going to equal gravity in. So mg cosine theta is going to be the same as Fg in. So let me say that my normal force is going to be mg cosine theta. Now, if these two are equal, then my acceleration is going to happen between these two, where my force of friction is going to be greater than my downward force. What is my force of friction? Well, my force of friction is mu times my normal force. So that's going to be mu times mg cosine theta. That's my force of friction. When I look at what my net force is, it's going to be the difference between down and friction. Since it says she's skidding to a stop, I can say that my net force is going to equal my friction minus my down force, because the difference between these two is going to give me my net force up the slope. So that is going to be my force of friction minus my force of gravity down the slope. And if I work that out, I can see that my net force, let's plug these in, is my force of friction, which is mu mg cosine theta from this, minus my force of gravity down the slope, which is which is just mg sine theta, right? My force of gravity down the slope, mg sine theta. So ignore that. So that's my net force. What's my acceleration? Remember, my acceleration is my net force divided by my mass. So A is F net over my mass. Well, if I divide all of this by mass, it's mu mg cosine theta over m minus mg sine theta over m, and look what happens happens to the mass. It's up and down both places. Whoops, there we go. So now I know my acceleration is going to be mu g cosine theta minus g sine theta is my acceleration. So over here, my acceleration is going to be mu g cosine theta minus g sine theta. That comes from all of this. So now I know my acceleration. Now I'm ready to plug that in here, solve for x. You're good to go.